we believe that and think plants are peaceful, lovely, and beautiful creatures. We give a red carpet to those we love, but in fact, there are some dark faces behind the plants. How? Imagine and visualize a farmer. What happens to his efforts when he keeps working sacrificially and waits patiently for a good product, but at the end, he doesn't have the quality product that he waited for? So, what must be his problem? Aren't we available to think of an idea to help the farmer? Or aren't we capable to increase the productivity of a plant by doing some experiments? These questions lead us to discoveries. Thinking is important. As a philosopher says, I live because I think. I'm living. That's why I'm thinking. So, to every problem, there is a solution, but if we think. And the solution is, of course, science. So, what is that science? The science is named Allelopathy. So what might be that allelopathy? Allelopathy has been recently developed as a branch of science dealing with the interference of crop plants and vice versa. The metabolic releases that a plant releases during several processes affects another plant in the neighboring area. How? You could see in the picture that a plant releases some secondary metabolites, but it affects the plants around it that are living in the neighboring area. These secondary metabolites are called allelochemicals. That a plant releases during several processes. What might be the processes? Leak out through glands on roots or in leaves. A plant releases this allelochemical during this process from its leaf or root. Released by the decay of fallen leaves and dead roots. In autumn, it's usually happening. And also, leach from the leaves when rain or fog passes over the leaf and drips off. When there is a fog on the plant, the stomata of a plant, which is a tiny opening in the leaf, begins to release some secondary metabolites, which are called allelochemicals. As you can see in the picture, a plant can release allelochemicals through its leaves and roots to affect the growth of another plant. Here we did a procedure to see that if the plants have dark faces on wheat, because wheat is the most valuable and most abundant crop plant that is in Kurdistan region. So we chose 8 different plants, Helianthus and American Helianthus, which are known by common name sunflower, and also Medicago and Trifolium, which are 2 plants in the pea family. Triticum, bread, Triticum, durum. What are they? We chose weeds to know if they have effect on the growth of another weed. We also chose Zea, which is known by their common name corn. So, how was the procedure? What we did? We plant 8 different plants in a pot and let them germinate, grow for themselves for a period of time. After that, we took the whole plant and brought to our laboratory. Then, we made a powder of a plant and mixed the powder with distilled water and put in a beaker. So this is a mixture that we form by allelochemicals. After that, we made 2 replications for each plant. As you can see, there are 16 petri dishes and 1 for control to all of them. We place the wheat seeds inside each of these petri dishes and count the days that the plants have an impact on wheat. After several days of counting the impacts, we could realize that the plants that we have chosen showing smiley faces. We collected again the plants and found out several data by doing some procedures. But the thing that is important is that we chose a plant to increase the productivity of a plant. But we saw that it makes the plant larger and stay healthier. So after these all experiments, we took out this data. Germination speed, these are the species extracts that we use in our experiment. Zea, we found it the most valuable and the most healthy plant to wheat. It germinated the speed of a wheat 14% more than its normal. This effect is on the some plants shoot system of wheat. How about the root system? Doesn't it have any effect on the root system also? Yes, it has. We found trifolium, which is a member of the pea family. Radical length, which is one of the shoot system parts of a plant. 26%, 26 centimeter, it grew larger during our experiments. And we found that it is more efficient with the radical elongation speed. It increases the speed that a radical can increase. So, and here I would like to make a comparison between the herbicides and allelochemicals. What are herbicides? Herbicide is a chemical that we think that we can use it for increasing the productivity of a plant. But this is a misconception. Why? Because herbicides kill the pests living in the area. It kills the insects that are living behind the plants. And when it kills, it causes damage of irrigation. And also it increases the yield loss. In that point, we can realize that the farmer has used herbicide. That's why he hadn't the quality product that he has waited for. It damages the soil. It also pollutes the environment. We are already suffering from a polluted environment. So we think that by using allelochemicals, we have a green planet. Let's compare allelochemicals with herbicide. Allelochemicals, if we use instead of herbicide, it gains the resistance of a plant and soil. It doesn't kill the pests that live around the plant. And this is the way of saving water. It increases the productivity of a plant. How? For example, we need 1 year to have a product of wheat. But by using allelochemicals, we can have twice a year. It keeps an eye on the environment. As we said, it doesn't kill the pests that are living in the environment. Instead, it gains resistance for the plant. And it decreases expenditure, which is claimed to be economical. How? We pay thousands of dollars to get herbicides from the countries, but why don't we use allelochemicals, which are existing in our country, to increase the productivity of a most valuable crop plant that we have? And by using allelochemicals, we make the other countries to look at us and to know our experience in the field of increasing productivity of wheat plant. And also, we are going to be a green finger country.